Good morning, madam.
Good morning, Durvesh. Good morning.
Good morning, ma'am.
Good morning.
12 बज गए. Good afternoon, ma'am. Sorry.
లంచ్ టిఫినే చేసిన దుర్గేష్. లంచ్ అదే ఈ కరోనా నాకు ఇంకా తగ్గలేదు.
ఇంకా తగ్గలేదా మేడం?
ఏం అస్సలు ఓపిక లేదు, కానీ మీకు మళ్ళీ టైం లేదు కదా అని చెప్తున్నా. నాకు
ఏ మేడం ఇంత ఇంత టైం పడదు కదా మేడం కరోనాకి?
ఆ రోజు నుంచి అసలు తగ్గలేదు నాకు.
అయ్యో.
ఉంది ఇప్పుడు పాపం
కొంచెము అది ఆయుర్వేదిక్ హోమియోపతి కూడా వాడండి మేడం, ఎందుకంటే అది కొంచెం ఫాస్ట్ తగ్గుతుంది మేడం మీకు. లేకపోతే ఇంత 7 days కన్నా ఎక్కువైంది కదా మేడం?
ఎక్కువ అయిపోయింది.
మేడం అది స్కాన్ చేయించారా మేడం? లంగ్ స్కాన్
చేయించలేదు, ఏది చేయించలేదు. అసలు బయటకు వెళ్ళి ఓపిక లేకుండా అసలు నాకు.
అయ్యో, ఒకసారి స్కాన్ చేపిస్తే తెలుస్తుంది కదా మేడం, మళ్ళీ ఇన్ఫెక్షన్ స్ప్రెడ్ ఏం కాలేదు కదా.
చేయించాలేదు రోజు అనుకుంటున్నా వెళ్ళాలి.
ఎందుకంటే చాలా రోజు అయింది కదా మేడం, అప్పుడే అన్నారు మీరు.
అవును, మధ్యలో కొంచెం ఫీవర్ తగ్గింది, దాని తర్వాత మళ్ళీ హెడేక్, కోల్డ్, కఫ్.
అది అంతా లింక్ ఉంటుంది మేడం.
అసలు లేదు, మనకి టైం లేదు. మళ్ళీ రేపు లాస్ట్ టైం చెప్పేస్తాయి ఇంపార్టెంట్ అని.
మేడం
నాకు నిన్ననే చెప్దామంటే నిన్న అస్సలు నాకు కూర్చోని ఒక్కలేదు అసలు.
అయ్యో, ఇది ఎక్కడి నుంచి వచ్చింది మేడం ఈ కరోనా? అది మాకు
ఈ పాపకి పుట్టింటికి వెళ్ళినాము, బస్సులో మాస్క్ పెట్టుకోలే నేను. ఎఫెక్ట్ పడింది నాకు.
అంతా తగ్గిపోయింది కదా మేడం కరోనా, మళ్ళీ సడన్ గా
మళ్ళీ వస్తూనే ఉంది కాదు. మళ్ళీ
మీరు వ్యాక్సినేషన్ తీసుకోవాల్సింది మేడం. మీరు
ఏ వ్యాక్సిన్ తీసుకున్నా వచ్చేస్తుంది కదా.
వస్తే కూడా అట్లీస్ట్ కొన్ని అవి యాంటీబాడీస్ ఫామ్ అవుతాయి కదా మేడం.
ఎంతమంది వచ్చారు? 5 members వచ్చారా?
ఈరోజు 5 వచ్చారు మేడం. 5, 4 నుబియా, జఫార్ బాబా, దాలియా దత్త, ఎవరో రెడ్మీ Note 8 అంటే ఎవరో
ఉన్నారు. ఏమో అంత ఆఫీస్ లో ఉండొచ్చు ఈ రోజు. సర్లే,
అంతా మార్చండి కదా మేడం, అంతా ఫైనాన్షియల్ ఇయర్ క్లోజింగ్ ఉంటుంది కదా.
అవునవునులే,
అందరు బిజీ బిజీ.
మళ్ళీ రేపు లాస్ట్ అయితే తర్వాత చెప్పడానికి ఉండదు
మేడం.
అట్లీస్ట్ ఏదన్నా వింటారా కొంతమంది అనేసి రేపు వాసంతి మేడం తీసుకుంటాన్నది. మార్నింగ్ నన్ను తీసుకోమన్నారు.
ఓకే మేడం.
రేపు ఫినిష్ చేసేస్తా దుర్గేష్. ఈ రోజు కొన్ని చెప్తాను.
ఓకే మేడం.
ఫినిష్ చేసేస్తా, ఏమున్నా నోట్స్ పెట్టేస్తానులే.
ఓకే మేడం.
ఒకవేళ టైం ఇస్తే ఇంకా ఏమన్నా ఇంపార్టెంట్ ఉంటే అప్పుడు పీపీటీ చెప్పేస్తా.
ఓకే మేడం.
ఇప్పుడు ఈవినింగ్ టైంలో చెప్తాను. ఎప్పుడైనా 6:30 నుంచి 7:30 అట్లా 1 hour అట్లా చెప్పిస్తే అయిపోద్ది. మండే, ట్యూస్డే అంటే నేను చెప్పేస్తాను. సరేనా?
ఓకే మేడం.
స్టార్ట్.
Good afternoon, ma'am. Ma'am, we can't understand Telugu.
No problem.
Ma'am, today Basanti ma'am take our class.
Dalia.
Ma'am, today Basanti ma'am take our class. Today Basanti ma'am take our classes.
Vasanti madam.
Yes, Vasanti ma'am told last week, no madam, that some problem.
Vasanti madam today ante mam తీసుకొనంది. So she
last week చెప్పారు మేడం, I won't take in on Saturday అని చెప్పారు.
Right. Tomorrow afternoon 2 to 5:30. So she will tomorrow.
Okay ma'am.
So in the morning I will take in the morning tomorrow. Okay. After the class. Okay.
Okay.
Right. So now can I start?
Yeah madam.
Okay, right. So today topic is radiation rates. So in that, this is very important. So they are asking in 5 marks question, fission and fusion. Okay. So the nucleus of radioactive material that emits 3 different types of radiation rays. So those are called, tell me, what is that? Radiation ray?
Alpha, beta, gamma.
Right. This one. Okay. So these three rays. So these 3 particles were named using the first 3 letters of Greek alphabet, right? So some later alpha particles were identified as helium, right? Helium 4 nuclei. And beta particles were identified as electrons. Okay. Then next gamma. Gamma rays as a form of electromagnetic radiation, like X-rays, except much higher in energy and even more dangerous to living systems, right? So due to the distinct electrical charge characteristics of the alpha, beta, and gamma rays, so they can be separated by directing a beam from a radioactive source through a magnetic field, right? So these radiations are released from the nucleus of an atom. So their behavior differs from one another, right? So through all these 3 causes some ionization and carry some penetration power, right? So you see one by one. So this is the picture of alpha, beta, and gamma. So first, alpha particles. So these are positively charged, and it made up of 2 protons and 2 neutrons from the atom nucleus, right? So alpha particles come from decay of the heaviest radioactive elements such as uranium, radium, and polonium, right? So even though alpha particles are very energetic, they are so heavy that they use up their energy over short distances, and these are unable to travel very far from the atom, right? So the health effect from exposed to alpha particles, those are depends greatly on how a person is exposed to that, right? So the alpha particles lack the energy to penetrate even the outer layer of your skin. So exposure to the outside of the body, that is not a major concern. And inside of your body, however, they can be very harmful, right? So if alpha emitters are inhaled, are swallowed, or get into the body through a cut, or the alpha particles can damage some of the sensitive living tissues, right? So the way these large heavy particles cause damage makes them more dangerous than other types of radiations, right? So the ionization they cause are very close together. They can release all their energy in a few cells. This result in more severe damage to cells and DNAs, right? So beta particles. Beta particles are small and fast moving particles with a negative electrical charge. So that are emitted from an atom's nucleus during radioactive decay. So these particles are emitted by certain unstable atoms such as like hydrogen 3, it's called tritium, and carbon 14 and strontium 90. Strontium 90. So the beta particles are more penetrating than alpha particles, but these are less damaging to living tissue and DNA because the ionization they produce are more widely spaced. So they travel further in air than alpha particles, but it can be stopped by a layer of clothing or by a thin layer of a substance, so such as aluminium. So I told in next slide here, right? So some beta particles are capable of penetrating the skin and causing damage, such as skin burns. However, with alpha emitters, beta emitters, so those are most hazardous when they are inhaled or swallowed.
Radiation weighting factor enter, madam.
Right.
అదేంటంటే these radiation weighting factor are called doses, ma'am. DOSE, dose.
DOS, huh?
DOSE, doses, ma'am.
Doses,
dose.
right.
Doses. So radiations will be measured in terms of doses will be measured in terms of curies. లేకపోతే becquerels, curies, లేకపోతే sieverts.
Okay, right. Okay, then next gamma rays. So gamma rays are weightless packets of energy. Those are called photons, right? So unlike these alpha and beta particles, which have both energy and mass, gamma rays are pure energy. So these gamma rays are similar to visible light, right? So but have much higher energy. So these gamma rays are often emitted along with alpha or beta particles during radioactive decay, right? So the gamma rays are a radiation hazard for the entire body. So they can easily penetrate barriers that can stop alpha and beta particles, such as skin and clothing, right? So the gamma rays have so much penetrating power that several inches of a dense material like lead or even a few feet of concrete, it may be required to stop them, right? So these gamma rays can pass completely through the human body. As they pass through, they can cause ionization that damage tissue and DNA, right? So you see some of the X-ray picture. So almost everyone has heard about these X-rays, right? So X-rays are similar to
Gamma rays.
Gamma rays. So in that they are photons of pure energy, right? So these X-rays and gamma rays have the same basic properties, but come from different parts of the atom, right? So the X-rays are emitted from processes outside the nucleus, but gamma rays originate inside the nucleus. Remember this word. So they also are generally lower in energy and therefore less penetrating than gamma rays. So X-rays can be produced naturally or by machines using with electricity, right? So all of you know, so literally thousands of these X-rays machines are used daily in medicines, right? So computerized tomography and commonly known as CTR CAT scan. CTR CAT scan. So uses a special X-ray equipment to make detailed images of bones and soft tissue in our body, right? So medical X-rays are the single largest source of man-made radiation exposure. Remember this word, right? So the X-rays are also used in some of the industry for inspections and also processes controls, right? So you see this picture, you can easily understand this picture. So the unique characteristics of these three types of radiation affect their
shieldings, madam? These are shieldings, madam? Shielding.
Shieldings. Just alpha rays ekkada varaku penetrate avutundi up to paper. Ante manaku first layer of your skin. Okay. So I can explain this your body figure. You see here, right? So whereas an alpha particles are stopped by a sheet, right? Sheet of paper. So beta particles are easily passes through paper from up to aluminum, right? So, but it's stopped by this aluminum plate. So, gamma rays is not impeded by the paper aluminum, but it is progress can be stopped by lead, right? So, the degree to which each of these three forms of radiation penetrates human tissue is the basis for limiting a person's exposure to radioactive materials. So you see here, so in terms of the impact of radiation on the human body, so you see alpha particles are generally stopped by your outer layer of skin. You see here, right? And pose no real harm to underlying this tissue, right? So beta particles, however, are not stopped by the protective layer of your skin, and it can damage deep or sensitive tissue here, right? And gamma rays likewise can penetrate deep into your body and cause harm, very harm up to here, right? So that's why it is necessary to wear specialized protective gear when working with radioactive materials. So in these rays, what rays are very dangerous?
Gamma rays, man.
Yes, right.
When it is taking in internal hazard, alpha, man. Internal hazard.
Right. Okay. So these are the alpha and beta and gamma rays. Then next, you see here, fission. So the nuclear fission is the splitted of a heavy nucleus into two lighter ones, right? So, and fission was discovered in the year of 1938 by the German scientists, Otto Hahn and Fritz Strassmann, right? These two peoples. So who bombarded a sample of uranium with neutrons in an attempt to produce new elements with Z92. 92. Okay. So they observed that lighter elements such as barium means Z56. So they were formed during the reaction, and they realized that such products had to originate from the neutron-induced fission of uranium-235. Uranium-235. Okay, you see this one fission process. So when a radioactive materials, so when a neutron is fired at high speed into an atom of uranium, so it will split the atom in a process. So that is called fission, right? So you see the process. So the stability of the nucleus of an atom that is maintained by the balance between the repulsive electrical force among the photons and the attractive nuclear forces holding the nuclear together with uranium. So this balance is unstable. Thus, when a fast-moving neutron collides with the nucleus of uranium-235, right? You see this process. So it is stretched into an elongated shape, right? So this elongated shape that tips the balance in favor of the repulsive forces, and this uranium-235 atom, you see how to splits here from to here, right? So into fragments of kryptons, right? Kr and barium, Ba. So three neutrons are also generated from this powerful release of energy. So these three forcefully ejected neutrons can each strike an atom of uranium, resulting in the case of an atomic bomb, right? So it is a catastrophic chain reaction, right? You see here also same. So the nuclear fission process is also the source of energy used to operate nuclear power plants in a controlled environment. The tremendous heat generated by splitting this uranium 235 is used to produce steam that drives a turbine to generate electricity, right? Then next, fusion. So the word fission, it means a merging of separate elements into a unified whole, So the nuclear fission refers to the union of atomic nuclear to form heavier nuclear, that is resulting in the release of enormous amounts of energy, right? So you see this picture. So fusion occurs when two atoms lump together to form a heavier atoms, like when two hydrogen atoms fuse to form one helium atom, right? So fusion takes place when two low masses isotopes, typically the isotopes of hydrogen, under conditions of extreme pressure and temperature, right? So this is the same process that powers the suns, right? So atoms of this tritium and deuterium, right? So under extreme pressure and temperature to produce a neutron and helium isotope. So the sun uses 500 metric tons of hydrogen per each second, right? So it creates huge amounts of energy, right? So which is several times greater than fission. So it also does not produce highly radioactive fission products, right? So these fusion reactions are being studied by scientists, but those are difficult to sustain for long period of time because of the tremendous amount of pressure and temperature needed to join the nuclear together, right? So you see the difference between the fission and fusion. You see here, so fission means split a larger atom into two or more ones, right? So fusion means opposite. So joins two or more lighter atoms into a larger one, opposite, right? So you see the difference between, so you can write in your examination, so difference between fission and fusion. So this is the 5 marks question, right? So you see here, so in fission, required high temperatures, not required, right? So in fission, high temperatures also not required and produces highly radioactive particles. In here, few radio particles produced. And here, fission reaction does not normally occur in nature, but fusion occurs in stars such as the sun. So in fission, used in power plant for generation of power, and it is an experimental technology. So you read all of this one, okay? So these are the differentiation of this fission and fusion, okay? So just wait, I will upload another PPT here also. Okay. So now nuclear weapons, right? So this is also very important topic in your examination. Okay, right. So nuclear weapons. Nuclear weapons are the most dangerous weapons on the earth, right? So all of you know about that. So one can destroy whole city. So potentially killing millions and jeopardizing the natural environment and also lives of future generations through its long-term catastrophic effects, right? So it is mostly very, very dangerous, right? So the dangers from such weapons arise from their very existence, right? You see some of these pictures, nuclear weapons here, okay? So the nuclear weapons, so also called an atom bomb, right? Or atomic bomb, a nuclear warhead, right? Or nuclear bomb. So it is an explosive device that derives its destructive force from nuclear reactions, either fission or from a combination of fission and fusion reactions, right? So both bomb types release large quantities of energy from relatively small amounts of matter. So remember, so the nuclear weapons possess enormous destructive power from nuclear fission or combined fission and fusion reactions, right? So in United States and also Russia, UK, China, France, and India. So these countries only have conducted thermonuclear weapons. You see this, thermonuclear weapon tests. So, but whether India has detonated a true multi-staged thermonuclear weapon is controversial. So that is important. So in the year of 2016, January, in North Korea, it claims to have tested a fusion weapon. So this claim is disputed. So the thermonuclear weapons are considered much more difficult to successfully design and execute than primitive fission weapons, right? So almost all of the nuclear weapons deployed today use the thermonuclear design because it is more efficient, right? So in the Teller-Ulam design, T-E-L-L-A-R, Teller-Ulam, U-L-A-M, the Teller-Ulam design, which accounts for all multimigation yield hydrogen bombs. So that is accomplished by placing a fission bomb and fusion fuel. It means tritium, deuterium, or lithium deuteride, right? So in proximity within a special radiation reflecting container. So the thermonuclear bomb works by using the energy of a fission bomb to compress and heat fission fuel. So when the fission bomb is detonated, the gamma rays and X-rays emitted first compress the fusion fuel. Remember this. So then heat it to thermonuclear temperatures, right? So the ensuing fusion reactions, it creates enormous numbers of high-speed neutrons, which can then induce fission in materials not normally prone to it. So such as depleted uranium. So each of these components is known as, what is that? Stage. So with the fission bomb as the primary and the fusion capsule as the secondary. So in large migration range hydrogen bombs, about half of the yield, it comes from the final fissioning of depleted uranium. Right? So virtually all thermonuclear weapons deployed today, that is use the two stage. Those are primary and secondary, right? So that is design described above, but it is possible to add additional fusion stages. So in each stage, igniting a larger amount of fusion fuel in the next stage. Remember this. So this technique, it can be used to construct thermonuclear weapons of large. So in contrast, that is fission bombs, which are limited in their explosive force. So the largest nuclear weapon, so ever detonated. So the, what is that? TSAR. Tsar Bomba. Tsar Bomba. B-O-M-B-A. Tsar Bomba of the USSR, which released an energy equivalent of over 150. How much? 50 megatons of TNT. It was 3-stage weapon. So most of the thermonuclear weapons are considerably smaller than this, right? So in the year of 1930s, the United States, the United Kingdom, and also Canada and Free France. So these are collaborated during in the World War II in the Manhattan Project. So those are to build a fission weapon. So it is also known as atomic bomb, right? So in the year of 1945 August, the atomic bombings of Hiroshima and Nagasaki. So all of you know about that Hiroshima and Nagasaki. So they were conducted by the United States against Japan at the close of that war, and standing to date as the only use of nuclear weapons in hospitals. So the Soviet Union started development shortly after with their own atomic bomb projects, right? And not long after, both countries were developing even more powerful fusion weapons. Those are called hydrogen bombs, right? Hydrogen bombs. So what is the atomic bomb? So fission. Fission means atomic, right? So hydrogen. So this is called hydrogen bomb. So in the year of 1950s, so in 50s, Britain and France, they built their own systems. And also the list of states with nuclear weapons, it has gradually grown larger in the decades since, right? So the first test of fission, that is called atomic bomb, right? So bomb released an amount of energy, approximately how much? Equal to 20,000 tons of TNT. TNT means trinitrotoluenes, right? And the first thermonuclear bomb. First thermonuclear bomb. So that is test release energy approximately equal to 10 million tons of TNT, right? So this is first fission bomb and this is first fusion bomb, right? So the nuclear weapons have been used. Remember this word, nuclear weapons have been used twice in a war, okay? Only twice. So both times by the United States against Japan near the end of the World War II, right? So the Hiroshima, a manufacturing center of some 350,000 people, located about 500 miles from Tokyo city, it was selected as the first target, right? So after arriving at the US base on the Pacific island of Tinian, so the more than 9,000, how much? 9,000 pound uranium-235 bomb was loaded, brought a B, that is called B-29 bomber. Christian, you see here this figure, Enola Gay. So this plane is called Enola Gay, right? So this is the 9,000 pound uranium-235 it has, right? So the US Army Air Force denoted using this Enola Gay plane dropped a uranium gun type fission bomb on the year of, you see here, August 6th, 1945. At the time, early in the morning, 8:15 in the morning. So that is nicknamed. Nicknamed is Little Boy. Nickname is Little Boy over the Japanese city of Hiroshima. So, and it is exploded 2,000 feet above Hiroshima in a blast. So equal to how much? 12 to 15,000 tons of TNT and destroying 5 square miles of the city. Right? So the Hiroshima's devastation failed to immediate Japanese surrender. Right? So then after 3 days, after incidents of 3 days, it means on August 9th, right? So what happens there at 11:02 a.m. in that morning, again, the US Army Air Force is detonated a plutonium. You see here, plutonium implosion type fission bomb, nicknamed Fat Man. Fat Man. So this name is Little Boy and this name is Fat Man over the Japanese city of Nagasaki. So this Little Boy is on Hiroshima and this Fat Man on Nagasaki. Right? So remember these two words, Little Boy and Fat Man. Right? So it is more powerful than the one used at Hiroshima. So the bomb weighed nearly how much? 10,000 pounds. And it was built to produce to how much? 22 kiloton blast. 22 kiloton blast. So the topography of Nagasaki, which was nestled in narrow valleys between mountains, reduced the bomb's effective and limiting the destruction of 2.6 square miles, right? So these bombings caused injuries that resulted in the death of approximately 2 lakhs people, civilians and military personnel, right? So you see this figure. So this is the Little Boy. Weapon is Little Boy weapon. Use this one. Here. So this plane is Enola Gay plane. Okay. These are the people who threw the bomb in the Nagasaki and Hiroshima. Okay. You see the devastated city of Hiroshima after the atomic bomb blast. And you see the difference between, so this is the 2007 recent, the 1945 of Hiroshima. Okay. So you see there's some aerial picture photography. So before and after this picture. So you see here, empty here. This is the total city of Nagasaki. So after bombing, you see this place. So this. So the atomic bomb mushroom clouds over Hiroshima and Nagasaki. So this is, what is this? You remember this one, little boy and fat man. This is little boy, this is fat man. Nickname will wait kunnaru vallu ikka bombu lesindi aga. Okay. The next, I just wait. I will upload another PPT. Okay. So, any doubts in this PPT?
No, ma'am.
PPTs lo elanti questions adugutaru madam?
Then me questions are types of nuclear weapons anta. Just okay. Types of nuclear weapons. Okay.
అంటే మనం అంతా థర్మోన్యూక్లియర్ అన్ని ఎక్స్ప్లెయిన్ చేయాలి.
అన్ని రాయాల్సిన అవసరం లేదు, జస్ట్ మీకు తెలియడం కోసం ఎక్స్ప్లెయిన్ చేశాను నేను.
ఓకే మేడం.
సో దే ఆర్ ఆస్కింగ్ ఓన్లీ టైప్స్ ఆఫ్ న్యూక్లియర్ వెపన్స్. ఓకే. ఆర్ రైట్ అబౌట్ హిరోషిమా నాగసాకి బాంబ్ బ్లాస్ట్ లైక్ దట్. ఏముండదు, సింపుల్ ఇది. సో జస్ట్ వెయిట్. PPT, it is visible or not? Durgesh?
It is visible, madam.
Okay, correct. Okay, right. So now, nuclear disasters. Nuclear disasters. So, so a nuclear and radiation accidents that is defined by the International Atomic Energy, IAEA. IAEA. So as an event that had led to significant consequences to people, the environment, or the facility. So the nuclear accidents are much larger in magnitude of effects than a typical radiation accident. So the prime example of major nuclear accident. So it is one in which a reactor core is damaged and significant amounts of radioactive isotopes. So those are released, such as in the Chernobyl disaster. Chernobyl disaster. In the year of 1986, and Fukushima Daiichi nuclear disaster. So this is in the year of 2011, and this is 1986. Okay. So the impact of nuclear accidents, it has been a topic of debate since the first nuclear reactors were instructed in the year of 1954. And it has been a key factor in public concern about nuclear facilities. So, the technical measures to reduce the risk of accidents are to minimize the amount of radioactive released to the environment. So it has been adopted. However, human error remains, and there have been many accidents with varying impacts and even incidents, right? So an example of radiation accident might be some event such as a radiography accidents. So where a worker drops the radioactive source into the river, but they quickly retrieves it, right? It means they bring back from there, right? So the radiation accidents are far more common than nuclear accidents, and those are often limited in scale. So the majority of the nuclear issue arise because of the use of nuclears of various applications, right? So in the year of 2009, 15% of the world's electricity came from nuclear power in the year of 2009. How much? 15%. So in 2005, nuclear power provided 6.3% of the world's energy and 15% of the world's electricity. So with the US, France, and Japan together accounting for 56.5% of nuclear generated electricity, right? So in the year in 2007, the IAEA report reported there were 439 nuclear power reactors in operation in the world and operating in how many countries? 31 countries. So as of 2014, there have been more than 100 serious nuclear accidents and incidents from the use of nuclear power, right? So you see types of accidents, right? So 57 accidents. How much? 57 accidents are severe incidents have occurred since the Chernobyl disaster. Chernobyl disaster. And about 60%. How much? 60% of the nuclear related accidents have occurred in the USA, right? So the most serious hazard to human health and environment, which is by the following steps of this incidents. You see here, these are the types of accidents: nuclear test and nuclear power plant accidents, and improper disposal of radioactive waste, and accidents during transport, and human error, and also lost souls, right? So you see one by one, nuclear test. So the nuclear tests, testing of atom bombs and also weapons under the oceans are underground, right? Oceans are underground. And nuclear power plant accidents, so which caused due to the failure of coolant and heat exchangers. Those are the reactor core, right? And improper disposal of radioactive waste. So it is the improper disposal of the nuclear waste, so which is produced during the fission action. Fission action. So the disposal, it has to be done by dumping the nuclear waste in concrete of steel barrels and bury them under the deep oceans or the seas. So if it is not done properly, it will result in these accidents, right? And fourth one is accident while transporting. So it is accident during transport of the nuclear waste or the radioactive materials, right? So the transport accident can cause a release of radioactivity resulting in contamination or shielding to be damaged, resulting in direct irradiation. So, for example, in Bolivia or Cochabamba city, so a defective gamma radiography set was transported in some of the passenger bus as a cargo. So the gamma source was outside the shielding. So, and it irradiated some other bus passengers, right? So the UK, it was revealed in a court case that is in the March 2000, I think 2002 month. Conditions. Right? Then next, human error. So humans have made errors. A lot, So while attempting to service plants and equipments, so which has resulted in overdoses of radiation, right? And last source. So last source accidents also referred to as an orphan source in which a radioactive source is lost, stolen, or abandoned. So these types of sources then might be cause the harm or the environment. And the others means some other accidents, it defy classifications. So these accidents happens when the unexpected occurs with a radioactive source. So for instance, if a bird were to grab a radioactive source containing radium from a window and then fly away with it, right? So it returns to its nest and then dies shortly afterwards from direct irradiation than a minor radiation accident. It would have occurred, right? So these are the types of accidents. And these are serious nuclear power plant accidents, very severe or serious, right? So you see, this is the very important. So in your examination, they are asking only one. You can, they are asking only write 3 Mile Island accident. So last time they are asking this question, 3 Mile Island accident or Chernobyl disaster or Fukushima Daiichi nuclear disaster. So these 3 are very, very important, right? So you should read. So these 3. So seriously, nuclear power plant accidents include this Fukushima Daiichi nuclear disaster. So that is the year of 2011, and the Chernobyl disaster, the year of 1986. The 3 Mile Island accident. This is also very, very important in the year 1979. So the nuclear power accidents can involve loss of life and large monetary cost for remediation work, right? So first you see here 3 Mile Island disaster. So this is the 3 Mile Island plant. Okay, so this 3 Mile Island nuclear power plant, it was built in the year of 1974. 74 on a sandbar on Pennsylvania River Basin. Pennsylvania's Susquehanna River Basin. ఇక్కడ రాశాను చూడండి. So it is just 10 miles down from the state of capital of, what is that? Harrisburg. Harrisburg. Okay. So the 3 Mile Island have 2 units. So unit 1 and unit 2, right? So unit 1 is called TMI 1 and TMI 2. 3 Mile Island 1, 3 Mile Island 2. Right? So in the unit 1, TMI 1, also called TMI 1, 3 Mile Island 1. Right? So it is an 820 megawatt, 820 megawatt Babcock and Wilcox pressurized water reactor and commercial operation on the 2nd September 1974. So, and unit 2 also Babcock and Wilcox pressurized water reactor. So this is, and it's slightly larger, 9.6 megawatts, and it went into commercial operation on December 30th, 1978. So now you see what happens in the 3 Mile Island accident. So the 3 Mile Island accident was a partial meltdown reactor number 2, this one, TMI 2, in Dauphin County, Pennsylvania, near Harrisburg, and subsequent radiation leak that occurred on the March 28th, 1979, right? So actually, this accident remains the worst accident in the history of US commercial nuclear power plant. This is the worst, right? So the accident released a very small amount of radioactivity, and it had no detectable health effects on plant workers or the public or the environment. So, but it brought about sweeping changes at the Nuclear Regulator Agency, Nuclear Regulator Agency, or Nuclear Regulator Commission, that is called NRC. NRC. You see, this is the TMI 2. So the NRC upgraded its regulations to related to everything from the reactor operator training and radiation protection and plant design and also operations and emergency response planning. So all of these changes significantly enhanced in US reactor safety, right? So what happened in that accident in 3 Mile Island? So 3 Mile Island, which we usually just call, what is that? TMI, right? TMI. So it had 2 pressurized water reactors, 2 pressurized water reactor. And TMI 1 entered service in 1974, and still operates now safely. And TM2, this TMI 2 was brand new when the accident occurred, right? So on the March 28, 1979, it happened to in this Unit 2 reactor. So when the reactor was operating at the 97%, you see here, 97% of power. So the reactor lost cooling the water in the secondary loop. So note that blue color is nope, right? So this event occurred around what is the time? 4 o'clock, around 4 o'clock in the morning. So, and the alarm sounded in the control room immediately. So within 1 minute, the reactor automatically shut down within 1 minute, right? So you see, within seconds of the shutdown, the pilot operated relief valve, that is called PORP, right? PORP. You see here this one. PORP, this one. So on the reactor cooling system, open and it was supposed to, right? So about 10 seconds later, it should have closed, but it remained open, leaking vital reactor coolant water to reactor coolant drain tank, this drain tank, right? So the operators believe the relief valve had shut down or closed because instrument showed them that a close signal, it was sent to the valve. So however, they did not have an instrument indicating the valve actual position, right? So the responding to the loss of cooling water, high pressure injection pumps automatically push replacement water into the reactor system. So as water and steam escaped through the relief valve and cooling water surged into the pressurized raising, you see here, pressurized the water level in it, right? So the pressurized is a tank which is part of the primary reactor cooling system, right? So it is maintain proper pressure in the system. So the relief valve is located on the pressurized, right? So in a PWR, like a TMI2 reactor, water in the primary cooling system around the core is kept under the very high pressure to keep it from boiling. So the operators responded by reducing the flow of replacement water. So their training told them the pressurized water level was the only dependable indication of the amount of cooling water in the system. So because the pressurizer level was increasing, so they thought the reactor system was too full of water, right? So they think about that only. So their training told them to do all they could be, to keep the pressurized from filling with water. So if it is filled, they could not control pressure in the cooling system and it might rupture, right? So the steam then formed in the reactor in primary cooling system, right? So pumping a mixture of steam and water and caused the reactor cooling pumps to vibrate because the severe vibrations could have damaged the pumps and made them unusable, right? So the operators shut down the pumps, that's why. So this ended forced cooling the reactor core. So however, as reactor coolant water boiled away, the reactor's fuel core was uncovered and it became even hotter. So the fuel rods were damaged and released radioactive material into the cooling water, right? So at the time 6:22 a.m., the operators closed a black valve here, this black valve between the relief valve and the pressurized, right? So this action stopped the loss of coolant water through the relief valve. So however, superheated steam and gases blocked the flow of water through this core cooling system, right? So after 2 days later, however, on the March, this is 28th, right? 28th March and 30th March. After 2 days, a bubble of highly flammable hydrogen gas was discovered within the reactor building. In this building, right? So the bubble of gas was created 2 days before when exposed poured material reacted with superheated steam, right? So on March 28th, some of this gas has exploded. So that is the reason. So released a small amount of radiation into the atmosphere. So at that time, plant operators had not registered the explosion, right? So which sounded like a ventilation door closing. So after the radiation leak was discovered on where March 30th, right? So some of the residents were advised to stay indoors, and experts were uncertain if the hydrogen bubble it would create further meltdown or possibly again explosion. And as a precautions, governor through the advised pregnant women and preschool age children to leave the area with a 5-mile radiation of this 3-mile island facility until further notice, right? So this led to the panic the governor had hoped to avoid. Within days, more than 1 lakh people had fled surrounding towns, right? So now this 3-mile island TMI-2 reactor was now shut down. So it took 12 years and it cost how much? $973 billion to decontaminate to low levels of radiation. So there were 10.6 megaliters of radioactive coolant that were processed, stored, and safely evaporated. So about 100 tons of damaged radioactive fuel was put into 342 canisters. So they were shipped to the Idaho National Laboratory. Idaho, IDAHO, Idaho National Laboratory, and stored in concrete containers, right, in this laboratory. So now, this is the 3-mile island accident and Chernobyl disaster. So Chernobyl disaster, you see this is the Chernobyl map. So this accident in the year of 1986 at the Chernobyl nuclear power station in the Soviet Union. So the worst disaster in the history of nuclear power generation, right? So the Chernobyl power station was situated at the settlement of Pripyat. You see here this one, TRYPYAT. So this is the 10 miles or 16 kilometers northwest of the city of this Chernobyl and 60 miles north of Kyiv. ఇప్పుడు అన్ని ఇక్కడ ఇది ఇక్కడే కదా యుద్ధం అవుతుంది కదా రష్యాకు ఉక్రెయిన్ కి
Kyiv, madam.
Kyiv, so this Kyiv, Ukraine, right? So the station consisted of 4 reactors. So each capable of producing how much? 1,000 megawatts of electric power. So it had come online in 1977 to 83. So there were 4 reactors. You see, 4 reactors which was installed in USSR on various years, right? So when technicians at reactor unit 4, these are the 4 units, okay? So in the technician at this reactor 4 attempted a poorly designed experiment, right? So workers shut down the reactor's power regulating systems and its emergency safety systems. And they withdraw most of the control rods from its core while allowing the reactor to continue running at 7%. How much? 7% of power, right? So these mistakes were compounded by others. And at the time of 1:23 a.m. on April 26th, 1986, the chain reaction in the core went out of the control. So several explosions triggered a large fireball and blew off the heavy steel and concrete lid of the reactor. So this and the enduring fire in the graphite reactor core. So that is released large amount of radioactive material into the atmosphere. So where it was carried great distances by air currents. So a partial meltdown of the core also occurred. So between 50 to 185 million curies of radionuclides escaped into the atmosphere. Right? So approximately, so in the year of 2005 to 2005 September, the Chernobyl Forum, comprising 7 United Nations organizations and programs, the World Bank and the governments of Belarus, Russia, and also this Ukraine, published the 3-volume and 600-page report assessing the impact of this accident on public health. How much? 600-page report chesaranta vallu. 600 pages report. Okay? So 3 volumes. So approximately 50 emergency workers had died of acute radiation sickness shortly after the accident. So, and 9 children had died from thyroid cancer because of radiation exposure, right? So from among the 2 lakhs emergency workers who were present at the site in the first year following the accident. So the people who were evacuated in the 2,70,000 residents of the most heavily contaminated areas. And additionally, 3,940 people were likely to die from cancer during prolonged period after the accident. So you see now the Chernobyl city is empty. So where the radiants are emitted from that place, it is made unfit for any life to survive. You see, right? So had 4, here you see, had 4 nuclear reactors is there, right? So this 4th reactor got exploded here. So which exploded the 3rd reactor, which was fit closed by there, right? So this is the picture of the complete destruction of 4th and the 3rd reactor. So you can see how it was completely destroyed and how it is exploded and burned, right? So you see the before accident and the after accident figures. This is the Chernobyl city. And before accident. Then next, after accident. Okay. The next, Fukushima disaster. Fukushima Daiichi disaster. So this nuclear disaster took place due to the explosion of nuclear reactor. So which arose due to the failure of the heat exchangers on 11th March 2011. So due to an earthquake followed by tsunami, which over the city of Fukushima Daiichi. You see this picture, Fukushima Daiichi. So during this time, the heat exchanger failed to exchange the heat between the reactor core and the coolant system, right? So which the reactor core completely melted down and the reactors exploded. So, but it was reported that there is no loss of lives, right? So, but there was lost the environment, and the whole of the city was completely destroyed, right? So it was said that more than how much? 1 lakh, more than 1 lakh people were evacuated. So knowing this explosion immediately, so that there was no life loss reported, right? So in this, immediately after the earthquake, all safety systems in each unit were operable. So though a few were slightly damaged. So however, less than 1 hour after the earthquake or tsunami struck the shoreline where the reactor units were built. So the tsunami reached the heights much greater than the reactors were designed to withstand, and ultimately it cut off the main power supply to the facility and damaged the backup generators by flooding their housing structures. So although the reactors withstood both an earthquake and a tsunami beyond their design requirement, so the prolonged power outage drained backup batteries incorporated into the emergency core cooling systems, so which led to a loss of capacity to remove decay heat. So that despite the best effort of the reactor operators and the emergency responders, rising temperatures within each reactor's core eventually caused a partial meltdown of the fuel rods and a fire in the storage reactor, explosions in the outer containment buildings, and the release of the radioactive steam into the atmosphere or air, and the leakage of radioactive water into the oceans, right? So as workers struggle to cool and stabilize the 3 cores by pumping seawater and boric acid into them. So the government officials established almost 30 kilometers evacuate zone around this plant. So approximately 1 month after the initiating event, the reactor cores were stabilized and cracks in the foundation of the containment vessels were sealed, and irradiated cooling water begins to be pumped to a storage building until it could be properly treated, right? So you see, this is the some of the Fukushima renewable energy hub picture. So these are the 6 reactors here, right? So this is the Fukushima Daiichi. So it is situated in Japan, right? Near the coastal areas of Pacific Ocean, right? Where the nuclear reactor got exploded due to the reactor core melted down, right? So you see, these are the pictures. You see here. So the most severe and worst nuclear accidents in the past 50 years. You see here one by one. So now, so this is the 15 marks question on your examination. So they are asking most severe or most worst nuclear accidents. You write any 10. Okay. You can write recently also any, you know what you know, you write. So you see here, first, in the year of 1969, Switzerland, right? And what is the reason? The power excursion and explosion of experimental reactor. And 79, US, I already told about this 3 Mile Island, severe damage to reactor core. And in the year of 1986, and Ukraine, Chernobyl, so this is also second one. And 87 in Brazil, so radioactive contamination, this is the reason. And the year of 1993, Russia, and explosive mechanical failure. and 1919 and Japan. So fatal overexposure of workers, and also 2005. So in US, that is the nuclear material leakage. So this is the accident. And next 2006, Belgium. So what is the reason? Worker exposed to high dose of radiation. So this is the reason. And 2011, in Japan, Fukushima, large external release of radioactive materials. So this is the main reason. And these are the, you can write these examples and you can write these years. Okay. You can write only 10. And the latest ఏమున్నాయి దుర్గేష్? Nuclear disasters. Latest. I wrote up to 2011. Unnara? Anybody?
Yeah, madam. What, madam?
So, in 2011 వరకు రాశాను.
Okay, ma'am.
ఇంకేమన్నా ఉన్నాయా లేటెస్ట్?
లేటెస్ట్ న్యూక్లియర్ యాక్సిడెంట్స్ అంటే
ఏమున్నాయి నాకు ఐడియా లేదు. ఎందుకడు
లేటెస్ట్ ఇప్పుడు మన ఢిల్లీలో అయింది కదా మేడం ఒకటి, అంటే రేడియో యాక్టివ్ కోబాల్ట్ సోర్స్, అది ఒక దాని పేరు మర్చిపోయాను, ఢిల్లీలో రీసెంట్లీ అయింది మేడం. దే హ్యావ్ స్టోలెన్ ద కోబాల్ట్ సోర్స్. అది ఒక స్క్రాప్ షాప్ లో దే హ్యావ్ స్టోలెన్ అండ్ దే హ్యావ్ కెప్ట్ ఇట్. సో ఇన్ దట్ ఏరియా సమ్ మంచి పేరు మేడం అది.
ఓకే,
ఐ ఫర్గాట్ ద నేమ్. ఢిల్లీలో రీసెంట్లీ అయింది మేడం.
అదే ఎక్కడో విన్నాను కానీ నాకు అంత ఐడియా రావట్లేదు. సో
ఢిల్లీ మేడం, 1 సెకండ్ అని చెప్తా. ఢిల్లీలో ఐ థింక్ ఇట్ ఈస్ ఢిల్లీలో రీసెంట్లీ అయింది మేడం. ఆ ప్లేస్ చెప్తాను మేడం, 1 సెకండ్.
ఇన్ యువర్ ఎగ్జామినేషన్ దే ఆర్ ఆస్కింగ్ ఓన్లీ యు కెన్.
మాయాపూరి మేడం.
మాయాపూరి. ఓకే,
మాయాపూరి స్క్రాప్ షాప్ లో
మీరు అది కూడా రాసుకోవచ్చు. ఇప్పుడు రీసెంట్ ఏమైనా ఇన్సిడెంట్స్ అవుతే అవి రాసుకోవచ్చు మీరు. నేను ఇక్కడ నుంచి చెప్పాను 1957 నుంచి 2011 వరకు నేను రాశాను ఇక్కడ. ఇది 15 మార్క్స్ క్వశ్చన్ అడిగారు లాస్ట్ టైం. ఇదొకటి. దెన్ 3 మైల్ ఐలాండ్ అండ్ ఇప్పుడు ఫుకుషిమా. ఇంకేం చెప్పాను నేను? 3 చెప్పాను కదా. చర్నబోల్ డిజాస్టర్. ఈ 3లో కంపల్సరీ 1 అడుగుతాడు. దెన్ నెక్స్ట్ కెన్ రైట్ 10 ఎగ్జాంపుల్స్ ఆఫ్ రీసెంట్ ఆర్ ఎనీ పాస్ట్ ఎక్కడ ఉన్నా మీరు రాయొచ్చు.
ఇవన్నీ డయాగ్రామ్స్ కూడా వేయాలి మేడం?
డయాగ్రామ్స్ అవసరం లేదు, జస్ట్ మీకు చూపించడానికి ఎలా జరిగిందని జస్ట్ ఐడియా కోసం. నేను ఫిగర్స్ ఏం అవసరం లేదు.
ఓకే మేడం.
ఇవి జస్ట్ మీరు ఏ ఇయర్ లో ఏది జరిగింది. సో వాట్ ఇస్ ద రీజన్?
ఓకే మేడం.
రైట్ 4-5 లైన్స్ ఎనీ.
ఓకే మేడం.
ఓకే, ఎనీ డౌట్స్? నుబియా లేదా? నుబియా ఇలా క్వశ్చన్స్ అడగట్లేదు బాబు.
వాట్ మ్యామ్?
ఎనీ డౌట్స్ నుబియా? యు ఆర్ నాట్ ఆస్కింగ్ టుడే ఎనీ క్వశ్చన్.
No ma'am, I was
Nubia
just
madam is on fast. No energy.
Right.
You did not stop in between. You did not ask only, so that's why.
Oh, sorry. Okay.
You were saying continuously.
It's okay.
But no doubts in this, ma'am, because this is something which has happened. No, so you were telling everything.
Yeah, right.
So no doubts.
Okay.
నాకు ఇవన్నీ ఈ కోర్స్ ఆల్రెడీ రేడియేషన్ సేఫ్టీ ఆఫీసర్ దానిలో అయింది మేడం.
ఓకే, రీసెంట్ విజిటెడ్ ఇన్ ముంబై.
రీసెంట్ బార్క్ ముంబైలో దే కండక్టెడ్ ఎ కోర్స్ మ్యామ్. దే కవర్డ్ ఆల్ దీస్ టాపిక్స్ ఇన్ దట్ ఆల్సో. దిస్ గోయానియా యాక్సిడెంట్స్, ఈ మాయాపూరి యాక్సిడెంట్స్, ఈ రేడియేషన్స్ అన్ని కవర్ చేశాను మేడం. దే హావ్ కవర్డ్ ఆల్.
అవును, వాళ్ళ మెయిన్ అదే కదా.
అదే న్యూక్లియర్ ఫిజిక్స్ కదా మొత్తం.
న్యూక్లియర్ ఫిజిక్స్,
రేడియేషన్ అండ్ న్యూక్లియర్ ఫిజిక్స్.
యా.
అందుకని కొంచెం ఈజీ అయింది మేడం అండర్స్టాండింగ్.
ఓకే.
Ma'am, we have one more class.
Yeah. No class. I don't have patience.
It's okay madam. Tomorrow class is there na madam?
Tomorrow morning.
Okay, madam.
11 o'clock. Okay.
Okay, madam. Fine.
And
Okay.
tomorrow all 4 classes will be there or 3 classes?
Yeah, 4 classes.
Four.
Okay. Morning,
Okay.
I will take the morning, and Vasanthi madam will take the class at afternoon, 2 to 5.
Okay.
Okay, madam. Okay, madam. Thank you.
Thank you, ma'am. Ma'am, please share these PPTs.
Sure, Nubia. So I will upload the PPT.
Okay, ma'am. Okay, ma'am.